San Diego, California. October 1965. The production lines that once built the fastest bomber in the world go silent. Workers who spent a decade assembling machines that could outrun sound itself now walk out carrying cardboard boxes. No press conference, no farewell, just a quiet shutdown notice pinned to a factory door. 7 years earlier, this same company had built the B-58 Hustler, the first bomber in history capable of sustained supersonic flight, a machine so fast it set intercontinental speed records that would stand for decades. 3 years earlier, this same company had built the Atlas rocket that carried John Glenn into orbit, the first American to circle the Earth. Millions watched. A nation held its breath. The name on the rocket was Convair. This was not a company that failed to innovate. This was not a company that fell behind the technology curve. Convair built the bomb's delivery system and the bomber that could outrun any defense built to stop it. Sometimes in the same decade, sometimes in the same building, and within a few short years, it collapsed anyway. Not from enemy action, not from technical failure. From a bet, a commercial gamble made in boardrooms, far from any wind tunnel or launch pad, that miscalculated the one thing engineering excellence could never guarantee, a market willing to pay for it. This is the story of how a company can win the technology war and still lose everything. The story does not begin with a bomber or a rocket. It begins with a merger. One built not on shared vision, but on shared ownership. In 1923, Reuben Fleet founded Consolidated Aircraft in Buffalo, New York, before relocating the company to San Diego in 1935, drawn by the year-round flying weather and the open land along the bay. Consolidated built its reputation on flying boats and heavy bombers, aircraft engineered for range and payload over speed or agility. Across the country, a separate company carried the name of a man who never lived to see it succeed. Gerard Vultee, a talented young designer, founded what became Vultee Aircraft in the 1930s. He died in a plane crash in 1938 at 36 years old. The company kept his name and kept building. Both companies shared something more important than a coincidence of timing, a controlling investor. Victor Emanuel, through his holding company Aviation Corporation, AVCO, held major stakes in both Consolidated and Vultee. By 1943, in the middle of the largest industrial mobilization in American history, Emanuel pushed the two companies together. The result was Consolidated Vultee Aircraft Corporation. The industry shortened it immediately, Convair. The timing was not incidental. The United States was 3 years into a war that demanded aircraft production at a scale no nation had ever attempted, and Consolidated already held the answer in its design office. The B-24 Liberator, a 4-engine heavy bomber with greater range and payload capacity than its more famous rival, the B-17 Flying Fortress. What followed was less an aircraft program than an industrial phenomenon. The B-24 was built not only at Consolidated's own plants in San Diego and Fort Worth, but under license at Douglas, North American, and, in the war's most staggering production feat, at Ford's Willow Run plant in Michigan, where the automaker adapted assembly line manufacturing to aircraft production and, at peak, rolled a completed bomber off the line roughly once an hour. By the war's end, more than 18,000 B-24 Liberators had been built, more than any other American military aircraft in history, before or since. Convair's name was stamped into the largest aircraft production run the world had ever seen, but that number concealed a structural truth that would define everything to come. Convair had not built a business. It had built a war machine, one entirely dependent on a single customer, the United States government, and a single condition, that the government kept buying. When the war ended in 1945, so did the orders. Production lines that had run continuously for 4 years fell silent almost overnight. Convair, like every major wartime contractor, faced the same unforgiving question. What does a company built entirely around military demand do when the guns go quiet? The answer, for Convair, would not come from diversifying into commercial markets, not yet. It would come from a new kind of war, one without front lines, fought over a doctrine that did not yet have a name. And it would require an aircraft larger than anything Convair, or anyone, had built before. The peace that followed World War II lasted, in practical terms, about a year. By 1946, the wartime alliance with the Soviet Union had curdled into something colder and more permanent. American military planning shifted around a single, terrifying premise. The next war would be fought not with armies crossing borders, but with bombers crossing oceans, carrying weapons that could erase cities in an instant. The Air Force needed a bomber capable of reaching targets deep inside the Soviet Union and returning without refueling, without forward bases, without depending on airfields that might not survive the war's opening hours. The requirement had actually originated earlier, in 1941, when American planners feared Britain might fall and worried the U.S. would need to bomb Germany directly from North America. Germany surrendered before that bomber was needed. The Soviet Union made it necessary again. Convair had the answer already in development: the B-36 Peacemaker, the largest mass-produced piston-engine aircraft ever built. Its scale was almost absurd. A wingspan of 230 feet, wider than a football field, is long. 6 massive piston engines mounted in a pusher configuration, their propellers facing backward, later supplemented by 4 jet engines slung in twin pods, giving the aircraft the improvised nickname 6 turning, 4 burning. A range exceeding 6,000 miles without refueling, enough to strike Moscow from bases in the continental United States and return home. The B-36 entered service in 1948, and it anchored the newly formed Strategic Air Command, the organization tasked with America's nuclear deterrent, as its primary intercontinental bomber for most of the following decade. It was slow. It was ungainly. It was, by the standards that would soon define aviation, already something of a relic even as it entered service. But it could carry nuclear weapons farther than anything else in the American arsenal, and in the doctrine of the moment, that single capability outweighed every other consideration. The B-36 also dragged Convair into a fight that had nothing to do with engineering and everything to do with institutional survival, a preview of forces that would eventually consume the company itself. In 1949, the Navy publicly challenged the Air Force's growing budget dominance, arguing that carrier-based aviation, not a single fleet of giant land-based bombers, should form the backbone of American nuclear strategy. The dispute became known as the Revolt of the Admirals, complete with congressional hearings, leaked documents, and accusations that Convair had secured B-36 contracts through improper influence. The allegations of impropriety were investigated and found unsubstantiated. The B-36 program survived, but the episode revealed something Convair's engineers understood better than its executives. In the new era of American air power, the deciding battles would not be won in a wind tunnel. They would be won, or lost, in a congressional hearing room, over budget lines that had nothing to do with which aircraft actually flew better. The B-36 gave Convair its identity for the coming decade. The company the Air Force trusted with its most strategically vital bomber programs, the contractor sitting closest to the center of American nuclear doctrine. It was a position of enormous institutional power. It was also, though no one at Convair could have known it yet, the beginning of a dependency that would prove impossible to escape. Every dollar of the B-36 program flowed from a single customer, tied to a single doctrine, subject to change the moment that doctrine shifted. And doctrine was already shifting. Somewhere in the Convair design offices, a new project was taking shape. One built not for range and endurance, but for a single uncompromising goal that no bomber had ever achieved: to fly faster than the sound of its own engines. By the mid-1950s, the B-36's slow, lumbering profile had become a liability rather than an asset. Soviet jet interceptors and surface-to-air missiles were advancing fast enough that a bomber's survival could no longer depend on altitude and range alone. It needed speed, not incremental speed, but a fundamental break from every bomber that came before it. Convair's answer was the B-58 Hustler, and it did not simply improve on the existing standard, it discarded it entirely. The B-58 was the first bomber in history capable of sustained flight at Mach 2, twice the speed of sound, cruising at that speed for extended distances rather than achieving it only in a brief dash. Its airframe used the Delta wing, a triangular planform with no horizontal tail, chosen because it minimized drag at supersonic speeds while retaining enough structural strength to survive the aerodynamic stresses of sustained high-speed flight. Its skin was largely built from a bonded honeycomb sandwich structure, thin aluminum sheets fused around a lightweight aluminum honeycomb core, a manufacturing technique so far ahead of existing industrial capability that Convair had to develop entirely new production processes just to build the aircraft in usable quantities. The numbers the B-58 put on the record book were not incremental. In 1961, a B-58 flew from Los Angeles to New York in just over 2 hours, a transcontinental crossing at an average speed exceeding 1,200 miles per hour. That same year, a Hustler flew from New York to Paris in under 3.5 hours, smashing the existing transatlantic speed record. In 1962, a B-58 crew flew a round-trip flight from Tokyo to London by way of the United States that broke multiple distance and speed records simultaneously. The aircraft won the Bendix Trophy and the Mackay Trophy in the same period, cementing its reputation as the fastest operational bomber the world had ever seen. On paper, the B-58 was a triumph without qualification. In service, it revealed a truth that no speed record could disguise. An aircraft engineered at the absolute edge of what materials and aerodynamics could achieve was by the same measure engineered at the absolute edge of what a flight crew could safely control. The B-58 was brutally unforgiving. Its delta wing design required significantly higher landing speeds than conventional bombers, leaving almost no margin for pilot error during takeoff and landing. Its complex fuel system, structural sensitivities, and demanding flight envelope meant the aircraft required an exceptionally skilled and exceptionally well-trained crew simply to operate it safely, let alone employ it in combat. Over its operational history, the Air Force lost a significant portion of its B-58 fleet to crashes, a loss rate that stood out even against the generally high accident rates common to early jet-age military aviation. Some of the losses claimed the lives of the very test pilots and instructors most qualified to fly the aircraft. The cost of ownership was just as unforgiving as the cost of a mistake. The B-58 was extraordinarily expensive to build, expensive to maintain, and expensive to fly. Its complex systems and specialized components meant every flight hour came at a premium far beyond what a conventional bomber demanded, at a moment when the Air Force was managing a rapidly growing budget for an entirely different class of weapon, the intercontinental ballistic missile, which required no pilot, no crew training pipeline, and no runway at all. The B-58 entered full operational service in 1960. By 1970, barely a decade later, the Air Force retired the entire fleet, an extraordinarily short service life for a bomber that had, only a few years earlier, held nearly every speed record in its class. Convair had built the fastest bomber on Earth. It had not built the bomber the Air Force could afford to keep flying. The lesson embedded in the B-58's short life would repeat itself, in a different form, within the same decade. This time not in a cockpit at Mach 2, but in a boardroom, over a jetliner built for a market Convair barely understood. But before that reckoning, Convair achieved something that would outlast every record the B-58 ever set. A program that would carry the company's name not just across the sound barrier, but out of the atmosphere entirely. While the B-58 chased speed records inside the atmosphere, a separate Convair program was solving a problem with far higher stakes: how to deliver a nuclear warhead across continents in under 30 minutes, with no pilot, no crew, and no possibility of interception. The Atlas program began in 1946 as an early, largely theoretical Air Force study into long-range rocketry, and it languished for years with limited funding and limited urgency. That changed abruptly in August 1957, when the Soviet Union successfully tested the R-7, the world's first intercontinental ballistic missile. 2 months later, the same rocket family launched Sputnik into orbit. The American public and its government reacted with something close to panic. The nation that had assumed technological superiority over the Soviet Union suddenly faced the possibility that Moscow could strike the American mainland with a weapon no fighter jet could shoot down and no early warning system could stop in time. Atlas, still in development at Convair, was rushed forward under emergency priority. The missile that emerged was an engineering approach unlike anything built before it, and unlike anything built after. Atlas used a balloon tank structure. Its fuel tanks were not built with heavy internal framework. but as thin-walled stainless steel shells that held their rigid shape only when pressurized internally, the way an inflated balloon holds its form. Unpressurized, an empty Atlas airframe could not support its own weight. It would collapse under gravity alone. Pressurized with fuel and nitrogen, it became strong enough to carry a warhead, or later, a spacecraft, into orbit. The design shaved enormous weight off the missile, weight that translated directly into range and payload, but it left zero margin for error in fueling, handling, or structural integrity on the launch pad. Atlas achieved its first successful full-range test flight in November 1958, and it entered operational service as America's first operational intercontinental ballistic missile in 1959, giving the United States for the first time a weapon that could reach Soviet territory directly from American soil without depending on forward-based aircraft or Allied airfields. But Atlas's most enduring legacy would not be as a weapon at all. When NASA needed a launch vehicle powerful enough to put an American astronaut into orbit, it turned to the missile Convair had already built and proven. On February 20th, 1962, an Atlas rocket lifted off from Cape Canaveral carrying John Glenn aboard the Friendship 7 capsule, making him the first American to orbit the Earth. Glenn completed 3 orbits in just under 5 hours, and when the capsule splashed down safely in the Atlantic, it closed a chapter of Cold War anxiety that had begun with Sputnik and a sense of American technological inferiority. Convair's missile, built to deliver a warhead in an act of war, had instead delivered a human being into history, watched live by a television audience of tens of millions. For a brief singular moment, Convair stood at the exact center of American national pride. The same design office that had engineered a supersonic bomber, too dangerous for its own pilots, had also engineered the rocket that put an American in orbit and returned him home alive. No competitor could claim both achievements in the same decade. Few companies in the history of American industry ever occupied that position at all. And yet fame is not revenue, and national pride is not a balance sheet. Atlas belonged, structurally, to the same category as the B-36 and the B-58 before it. A single customer, government-funded program, brilliant in execution, but incapable by itself of sustaining a company the size Convair had grown into. Convair's leadership understood this, and in the same years that Atlas carried John Glenn into orbit, the company was already committing itself to a very different kind of bet. One made not against Soviet engineers or the laws of physics, but against Boeing and Douglas, in a commercial market Convair had never truly mastered. That bet would not go the way of Atlas. By the late 1950s, the commercial aviation market was transforming faster than at any point in its history. Boeing had introduced the 707 in 1958, and Douglas followed with the DC-8, giving major airlines their first true jet airliners, aircraft that could cross the country and soon the ocean in a fraction of the time of the propeller-driven planes they replaced. Airlines were racing to order jets, and the companies that could deliver them stood to capture a market unlike anything commercial aviation had seen before. Convair wanted in, and Convair's leadership believed it held an advantage neither Boeing nor Douglas could match: speed. The result was the Convair 880, announced in 1956 and named, with characteristic boardroom confidence, for its advertised cruising speed of roughly 880 feet per second. It was, in fact, the fastest commercial jetliner in the world at the time of its introduction, faster than the 707 or the DC-8. Convair followed it with a stretched, more powerful variant, the Convair 990. Coronado, developed specifically at the urging of American Airlines, which wanted an aircraft fast enough to compete directly against Boeing's flagship jet on premium transcontinental routes. The engineering held up. The 990 became, at points, the fastest commercial jet airliner in the world. Convair had done exactly what it set out to do: build a faster airplane than its 2 larger, better established competitors. It was the wrong thing to build. Airlines, it turned out, did not select jetliners primarily on the basis of raw speed. They selected them on operating economics, fuel burn per seat mile, passenger capacity, cargo capacity, and how efficiently an aircraft could be scheduled across a route network. The 880 and 990 were both smaller than the 707 and DC-8, carrying fewer passengers per flight, while their pursuit of speed came with a fuel efficiency penalty that made them measurably more expensive to operate per seat than their rivals. Convair had entered the jetliner race late. Boeing and Douglas already had a head start of 1 to 2 years in development and airline relationships before Convair's aircraft reached the market, and had spent that lead time optimizing for a metric that mattered to marketing brochures far more than it mattered to an airline's finance department. The order books told the story with brutal clarity. Boeing ultimately sold hundreds of 707s. Douglas sold hundreds of DC-8s. Convair, across both the 880 and 990, combined, sold barely more than 100 aircraft total, a fraction of what either competitor achieved and nowhere near the volume Convair needed to recoup its development costs, let alone turn a profit. TWA and Delta became major 880 customers. American Airlines flew the 990, but orders that should have poured in from carriers across the country simply never arrived in the numbers Convair's projections had assumed. Convair had entered the commercial jet age with a genuinely capable airplane, engineered by the same design culture that had built a Mach 2 bomber and an orbital launch vehicle. It had built an airplane that could beat its rivals in a straight line. It had built the wrong argument for an airline boardroom where the only number that mattered in the end was cost per seat, not feet per second. The bill for that miscalculation was about to come due, and it would be a bill larger than almost any single commercial aviation program in American history had ever produced. The final accounting, when it came, was staggering even by the standards of an industry accustomed to expensive failures. General Dynamics, the parent conglomerate that had absorbed Convair in 1954, reported losses from the 880 and 990 program totaling approximately $425 million. At the time, it stood as one of the largest single corporate losses in American business history, a figure that dwarfed the development costs of either aircraft and erased any hope that the commercial jetliner venture would ever approach profitability. The number was not an estimate absorbed quietly into a footnote. It became a public business scandal, prompting a shareholder lawsuit and congressional attention, and it triggered a wholesale change atop General Dynamics itself. The company's chairman resigned under pressure, and new leadership moved in with a single mandate: determine what remained worth saving inside Convair and cut away everything else. The 880's 990 disaster did not strike Convair in isolation. It landed at the exact moment the division's defense business, the foundation that had carried the company through the B-36, the B-58, and Atlas, was contracting on its own terms. By the early 1960s, American nuclear strategy was shifting decisively away from the doctrine that had built Convair's fortunes. The manned bomber, so central to the B-36 and B-58 programs, was losing ground to a new generation of solid-fueled intercontinental ballistic missiles, weapons like Minuteman, which offered faster launch readiness and lower operating costs than liquid-fueled missiles like Atlas or the bombers that had preceded them. Atlas itself was being phased out of frontline military service as a weapon, its combat role assumed by newer missile systems, even as its second life as a NASA space launch vehicle continued. The B-58, as already sealed by its own operating costs and safety record, was heading toward an early retirement that would remove it from service entirely by 1970. Defense contracts that had once flowed to Convair, almost as a matter of institutional habit, were being redirected toward newer programs at other companies, built around newer doctrine. Two pressures that had nothing to do with each other in origin were now compounding on the same balance sheet at the same moment. A commercial gamble had failed catastrophically, at a cost approaching $500 million. And the defense revenue that might once have absorbed that shock, or at least cushioned it, was itself shrinking. As the Air Force's strategic priorities moved on to systems Convair had no significant hand in building. For General Dynamics' new leadership, the math left little room for sentiment. Convair's aircraft division was not merely underperforming, it was actively consuming capital the parent company could not continue supplying indefinitely, with no credible path back to profitability visible on any near-term horizon. The engineering culture that had produced a Mach 2 bomber and an orbital rocket counted for nothing on a balance sheet that showed 9 figures of red ink and a shrinking defense pipeline behind it. The decision, when it came, was not framed as a punishment or a verdict on the people who had built the B-58 and Atlas. It was framed the way General Dynamics framed every major capital decision, as a matter of allocation. The aircraft division no longer justified the resources it required, and in October 1965, That determination became final. The announcement, when it finally came, carried none of the drama that might have seemed warranted for a company that had shaped Cold War air power and touched the edge of space. General Dynamics stated plainly that Convair's aircraft manufacturing operations in San Diego would be shut down. No single executive stood accused. No individual decision was singled out as the cause. The record shows a board reallocating capital away from a division that could no longer justify its share of it. An institutional verdict, delivered in the flattest possible language, on a company that had spent 2 decades building some of the most audacious flying machines in American history. The human toll was immediate and severe. Thousands of engineers, machinists, and support staff, many of whom had spent their careers building the B-36, the B-58, and Atlas, were let go as production wound down. San Diego, a city whose economy and identity had been shaped for a generation by Convair's presence, absorbed a labor market shock that rippled through suppliers and subcontractors across the region. There was no ceremony marking the closure of a division that had once employed tens of thousands at its wartime and Cold War peaks. There was a shutdown notice, severance processing, and an empty factory floor. What remained of Convair did not vanish entirely, but it survived in fragments, not as a company. General Dynamics retained the Convair name for a scaled-down division, redirected toward Atlas and Centaur rocket production for NASA and government space launch contracts, work that continued for years under a much smaller footprint. Remaining defense contracts, tooling, and personnel were absorbed piecemeal into other General Dynamics business units. Some capacity was repurposed toward missile and space systems work. Other assets were simply liquidated. There was no single dramatic ending. No bankruptcy filing, no auction of a shuttered headquarters, no final flight marking the company's close. Convair's aircraft manufacturing identity did not die in one moment. It was dismantled in pieces, absorbed into a larger corporate structure until the name that had once meant B-36 and B-58 and Atlas meant, within General Dynamics, little more than a legacy label attached to a much smaller and narrower operation. That dismantling is, in itself, the most important fact about how Convair ended. There was no individual official who ordered the destruction of a rival's company out of personal grievance, no forced transfer of patents at the point of political threat, no single villain a documentary narrator could name and blame. What ended Convair's run as a major aircraft manufacturer was a board's allocation decision, made in response to a commercial loss it could not absorb and a defense pipeline that no longer needed what Convair was built to supply. It is a quieter, less cinematic kind of collapse than betrayal or seizure, and, for exactly that reason, a more common one in American industrial history. Companies that build the most extraordinary machines are not protected from balance sheets. Engineering brilliance buys attention, prestige, and occasionally immortality. It does not buy solvency. What Convair had actually built, though, did not disappear when the company that built it did. Some of it was still flying. Some of it was still reaching orbit, and that legacy would carry the name forward in a way its own leadership, in 1965, could not have predicted. The B-58 Hustler's story ended cleanly and permanently. The Air Force retired the entire fleet in 1970, and no successor aircraft ever attempted what it had attempted. A sustained Mach 2 bomber built around a manned crew. The B-58 remains, to this day, a closed chapter. A machine that set records no one contested and then vanished from operational service faster than almost any bomber in Air Force history. Its airframes now sit in museums, static reminders of a design philosophy the Air Force never returned to. Atlas told a different story entirely, one that did not end in 1965 at all. The Atlas name and design lineage survived Convair's collapse as a manufacturing division, carried forward first under General Dynamics' scaled-down space launch operations, then through subsequent corporate consolidations across the American aerospace industry. Convair's Atlas legacy ultimately passed into Lockheed Martin and later into United Launch Alliance, the joint venture formed by Lockheed Martin and Boeing to consolidate American government space launch capability. The Atlas name itself continued into the Atlas V rocket, which flew for the United States government, commercial customers, and NASA for decades, a direct descendant, in engineering philosophy if not exact hardware, of the missile Convair rushed into production after Sputnik shocked a nation into panic. The rocket that carried John Glenn into orbit in 1962 had, in a very real sense, never stopped flying under one corporate banner or another, long after the company that built it had ceased to exist as an aircraft manufacturer. That is the paradox at the center of Convair's story. The company's name disappeared from aircraft factories, from airline fleets, from the org chart of General Dynamics itself, dissolved into a conglomerate too large to keep a struggling division's identity intact. But the engineering, the balloon tank structure, the propulsion lineage, the institutional knowledge of how to build a reliable orbital launch vehicle did not disappear with it. It migrated, company to company, contract to contract, outliving every boardroom decision that had once threatened to erase it. Convair was not undone by a failure of imagination. It built the fastest bomber of its era and the rocket that defined America's first triumph in human spaceflight, often within the same design offices, often within the same handful of years. It was undone by a miscalculation about what airlines would actually pay for, compounding at the exact moment its core defense business was already contracting. Two pressures that had nothing to do with the physics of flight and everything to do with the economics of building it. The name Convair no longer appears on any factory gate, any tail fin, any letterhead. But the machines it built, the ones that survived, are still flying, still reaching orbit, decades after the company that engineered them ceased to exist. The company vanished. The work it left behind did not.